Hi, I'm Emmanuel. I'm here to take you through an introduction to behavior-driven and test-driven development. So this is our agenda for tonight. First thing we're going to do is look at what BDD and TDD are separately. We're also going to spend some time looking at how we can use them together. We're going to look at the key terms associated with both of them. We're going to spend some time on Gherkin, which is a central bit to especially behavior-driven development. Look at some examples on that as well. And then we'll have a hands-on session to kind of practicalize the things we talk about. And then we'll close and have pizza. Behavior-driven development. So this diagram is a typical behavior-driven development cycle. The first thing you want is you describe behavior. You then define your requirements. These requirements are reflected in tests. You expect your test to fail initially. Then you adjust your code or develop new code. And then you expect your test to pass. And you can then refactor your code as necessary with the safety net of these tests you've written. So to kind of focus in a bit. So again, like the name entails, behavior-driven development is all about allowing how you expect the feature you're trying to add or create at the end. You're trying to allow how you want it to behave, or to sort of like, how you want it to behave to be at the center of everything you do. So before you write any line of code, you want that to be at your forefront. So that's why the first two steps are perhaps the most important, because you're going to describe the behavior and you're going to define these requirements. So behavior-driven development in general, its mission statement is sort of about fostering collaboration. So those first two steps are very important. And what you find more often than not is that, or in successful implementations of BDD, is that in describing behavior and defining requirements, you have product owners or business analysts or whoever is sort of the outsider stakeholder who owns whatever is being developed, sitting with developers as well as testers together to define what this behavior is going to be and then reflect it in requirements before going forward in the process. It's because, so I'm highlighting this because a lot of times you talk to people and they'll tell you, oh, they're doing behavior-driven development just because they're using maybe Cucumber, SpecFlow, JBehave, JGiven, whatever sort of BDD adjacent library is. But it is quite important early on that you understand that the process is all about collaboration and it's not just a tool, if you will. It's simply a software development practice. Test-driven development. So this is very similar to behavior-driven development, except that we're not spending time here describing behavior or defining requirements per se. So what you find is that test-driven development is more geared towards developers themselves, and it helps you to kind of write high-quality code. So what you have is that when you want to add a functionality, so say you're programming, you want to create a function to do a particular thing, you write a test that is supposed to reflect what you want that function to do, and then you go away and start writing that function. The idea would be that that test sort of keeps you in focus, because some of the issues you have as a developer, I think one of the chief issues I've noticed when working with other developers is that sometimes you're developing a function or you're developing a program and code, and instead of sticking to having each function doing one particular thing, so the single responsibility model, you sometimes get carried away and start doing multiple things within one function, and you end up with functions that are very massive and code that is kind of hard to explain. But when you write the test first, it allows you to kind of just cut things off to just one outcome first. And then you write code to sort of achieve that outcome. And then you can kind of write a new test, do the same thing, and you go on step by step with how you're progressing. It also kind of gives you a chance to be able to know exactly where you are in your code development. Because you can go through the tests and say, right, these tests are passing, so I've got my code up to being able to do this. And then you can go away, come back, as opposed to sometimes where people write codes without tests, and you have to kind of read and realize exactly where you are with the feature before you resume after a break. So again, looking at that diagram, you're looking at a red-green pattern. So you want to write the test, the test will fail initially because whatever functionality you're trying to add doesn't exist. Then you write the code to do it. You have your test that passes, and then you can refactor it to make your code a bit more clean. For example, maybe use a specific library if needed. But now you have your test as a safety net when you're doing your refactoring, that you can say, right, as long as my tests keep passing, no matter how much I refactor it, I know that everything is fine. And if you ever get to a point where your test should fail, right, you've gone off the tangent a bit. And the nature of the test will also kind of tell you exactly where you've gone wrong. More of this will probably be clearer by the time we get to the hands-on session. So using BDD and TDD together, so you end up with a cycle that kind of looks like that. So what you'd have would be a high-level feature or behavior that you define as a requirement, and then you implement it as a feature test. So that's your BDD part of the cycle. And to achieve that kind of massive feature, you go through different cycles of TDD in your code development till you get to the point where all your TDD tests are passing, and then your overall BDD test for your feature is then passing. So this is often what you find this is one of the best ways to kind of ensure really high quality software that all the stakeholders, so even the non-technical ones like we've mentioned, the product owners, the business analysts, the PMOs, they're happy with it because they've gone through whatever that feature test is when describing behavior and defining requirements. And having that blanket, and then the developers also writing their little smaller tests based on that and writing their code based on that test, just means that everything is sort of very easy to trace back, and it gives you a high confidence level because whatever change you're making, you have tests to kind of let you know if you've gone astray or if you're in order. So key terms about BDD. Obviously, there are a lot of different key terms, but I've kind of just shrunk down to these three. So the first one, example mapping. So an example mapping session is very key. So it's often the method people use to describe their behavior and define requirements. What you have in an example mapping session is you get the people in the room, so again, our stakeholders, so often we have the three, your product owner, your developer, your tester, and you people are in the room, and what you do is you're trying to understand the feature and the requirements properly. So you run through examples. So say, for example, I was developing a phone. The first sort of example we'd look at, it would be, if I type in my dad's phone number and I call it, I expect my dad's phone to ring. And you get to another example, which would be, I type in my mom's phone number and I expect my mom's phone to ring. So the good thing is, also, when you're doing example mapping, you still come up with groupings. So like now I've mentioned my dad's phone number and my mom's phone number. And you can do that for any number of people in the world. But you can now create a grouping, or what is normally called a rule, where you would say, if I dial in someone's phone number, I expect their phone to ring, or the phone attached to that number to ring. And then you can also have things like constraints. So sticking with that phone example, you would say, right, if the person is on another call already, I don't expect their phone to ring. So that's a constraint. So you're only having the feature where when you dial the number, it rings when the other person is not already on a call. So also, another thing you can kind of get out of an example mapping session is the need for a future feature. So you can say, right, we're doing calling now. It might be possible that we do a feature where when you call, again, like we have already, if someone's already on the other end is already on the phone call, you get told the number is busy, so you know why your call hasn't gone through. So that would be a different feature, and then you'll be able to go over that, and you just note that for now, and then come back to that later. A Three Amigos session. So the Three Amigos in a BDD context are product owners, business analysts, pretty much the stakeholders that people often term as not being very technical. Then the developers who write the code to implement the product or the feature, and the testers who are there to test it. So again, these Three Amigos sessions are going to have things like example mappings going on, all about describing behavior and defining requirements. Gherkin. So talking about Gherkin, we've kind of spotlighted collaboration with behavior-driven development just now. But like I mentioned, you have product owners or business analysts who are probably not the most technical people, and you have developers who are very technical, testers as well who are also technical. So Gherkin is sort of the language that's often used to be able to create an outcome of these Three Amigos sessions. So it's designed to be a very high-level language that reflects features that everyone can understand. So let's actually spend some time and look at an example of why Gherkin is important. So if you see on your screen here, the lady there is the product owner. She's talking about encouraging new users by giving new users a 10% discount. And then the guy in the green t-shirt is your developer who's already thinking of it in Java code. You know, he's already thinking of, right, 10% discount, this is how I'm going to kind of code it up. And your tester is already thinking of how we test it on the website, of saying, right, register as a new user, but bookworm, who I guess is no one's name, and then go through adding a particular item and verify the subtotal. So obviously this is a bit exaggerated, but the idea is that these three people kind of look at things from a different aspect. So it's nice to use Gherkin to be able to give an outcome that everyone's happy with. And when you use Gherkin, you come up with something like that. So you say, given the user has not ordered yet, again, a new user, when the user adds a book of a certain price, then the shopping cart is that particular price. So you see that sort of Gherkin scenario, if you will. Each of them can sort of take it away and use it for their purposes. The product owner can say, right, this is our 10% discount. He can give someone the Gherkin and say, all right, this is how it works. The developer can take that away, and he'll look at that while he's coding. The tester can take that away and use it to create his tests. So it serves everyone's purpose without going into extreme detail like the previous slide was doing. So a few of the key words with Gherkin. So again, we have feature, which is sort of a high-level description of a software feature, or it's normally about one line. So again, like we mentioned with a phone early on, your feature in that scenario would just be something like calling people. And then these features are broken into separate scenarios. So again, sticking with the phone example, you'd have a scenario when you dial in a correct phone number, and another scenario when you dial in an incorrect phone number, and what happens after. Now, these scenarios are often made up of three sort of components. And you have your given, which is an initial sort of context. So if we go back to our last example we saw here, again, the initial context is the user has not ordered yet, so it's a new user. You have your when, which should be an action or an event that takes place. And here, you look at that. This is what they do. They're adding a book with a certain price into their shopping cart. And then is your expected outcome. So what should happen at the end of this scenario? And here we're seeing a 10% discount has been applied. So another example of Gherkin, a feature, login functionality of Facebook. Given I'm a registered Facebook user, I enter in my username as username, my password as password. I should end up being redirected to the Facebook homepage. Right, so I was thinking just within ourselves we could kind of have an example. So this is a water dispenser. Up in Scotland, some people call it a water cooler, but whatever it is, that's why I decided to use a picture rather than the text. But so if you kind of think within yourself, like what would the Gherkin sort of a scenario with this look like? Just to kind of test yourself, I guess. So I'll just give it a minute and then I'll show what I think the answer, or what my answer was. That wasn't a minute, but yeah. So I went with the scenario of delivering cold water. So if the water dispenser has a full bottle of water, it's been switched on for about 20 minutes. When I push down the blue tap handle, I expect cold water to flow down. So again, quite simple. We're not going into the details of whatever voltage or whatever is being passed into the dispenser or wherever the piping is. We're just looking at it from a very high level what does it do, how do we expect it to work, essentially. So that's what Gherkin gives you. Right, our hands-on session. We're going to be using Python Behave, and we're going to look at producing a calculator type program that returns true when a correct expression is entered and false when an incorrect expression is entered. Right, so you want to go to the URL that you have on your little sheet, ldn.devopsplayground.com, and you'd have your username and password there. So if I enter mine, so if you log in with your username and password, you want to click on the VNC one. You should see this. Okay, to continue. All right, cool. So you've got two icons here, PyCharm and README. I want you to click on both to open them up. So the README here is just a sort of guide. So if, as I'm going on, you get lost, pretty much everything we're going to do is in here. So if you do get lost, just have a look, and you probably just be one copy and paste away from catching up. All right, does everyone have their PyCharm open? Cool. So if you look on the side here, I'd like you to click on the calculator.feature. Also, is my font size visible to everyone? You want me to get it bigger? Or is everyone all right? All right, cool. Right, so our feature file. So what we're saying here is that given I'm a user of the calculator app, which is the app we are developing, when I enter an expression, so the expressions are, we've just had 5 of them set up here. The idea is that it's just going to cycle through all these 5. Then the output is expected. So we've put what we expect as the output next to them. So again, the correct ones, 2 + 1 = 3 is correct, so we expect true. And if you look at the bottom one, 2 + 1093 is not 12. So that's false. Cool. So one thing I want you to see is if you open up your steps folder here and click on steps.py. So what you see here is that we've written sort of testing code, and we're not going to dwell on this too much, but we've written testing code to sort of mirror what we have in our feature file. So remember, we have given a user of the calculator app, so we've kind of written an implementation of that step here. The same thing of when I enter an expression and the output is expected. So the key thing to note here is also like, again, this is just a small example for us to kind of get our feet wet with BDD and TDD. But when you get into full-on implementations, you might find that you have different scenarios that, say this calculator app grows and has other things involved in it. You might have different scenarios where you start with given I'm a user of the calculator app. The good thing is you would not need to repeat this every single time. Your code will be able to say, right, you've already implemented I'm a user of a calculator app at one point, and it will cover it. Just wanted to touch on that because that's normally a question that people have. Okay. So,
calculator.feature, is that code? Is that actually machine possible, or is that just human readable? Is that
yeah.
Cucumber, or is this just human readable stuff for us? I'm not.
All right.
clear on this.
So we can go through it. So your feature files, right? They're in text,
Yeah.
but it is machine readable with your library. So here we're using Python Behave. So if, for example, I were to change that not to match what is in my feature file, your test would break. So that's kind of the advantage of BDD. fact that everyone understands this file, but it still contributes to your code.
Thank you.
Okay. So now what we want to do is if I go back to my slide here on BDD and TDD, which is what we're practicalizing. So we do have our feature test just now, which is our BDD. So we're going to run it and see that it fails. And then later on, we're going to do cycles of TDD to get to the point where our test passes overall. Sound okay to everyone? Awesome. So let's actually run these BDD tests. So if you click on terminal here, and you want to do cd test/features. Okay. And then this is a tricky one. You want to do Python path equals // behave. Right? Sorry. So Python path equals // space and then behave. Okay? So if we do enter, so if we do enter, sorry, are people still having trouble with the command? You want me to come back to it? So you do cd test/features first, then Python path equals // space behave. Okay? So if we have a look, is everyone okay? All right, let's give it a few seconds. Do you have something like this on your terminal screen now? Cool. So we want to kind of focus on our sort of summary here, which tells us 0 features have passed, 1 has failed. None of our scenarios have passed, so our 5 examples, they've all failed. And if we scroll up, you can kind of see what's going on. It's pretty much not been implemented, and that's pretty much how it's just broken for all our examples. So hopefully at the end we're going to run this again, and fingers crossed we'd have that actually working. Okay. So let's spend some time actually looking at, so here I kind of just, again, looked at one scenario, given that, 1 + 2 = 3, we expect it to be true. So this diagram sort of shows what we want to achieve. So the green bits at the end are sort of our input and output. So that's our feature test in general, so our BDD tests. So that's what we've just tested that fails. And then we're going to do TDD to implement the bit in the middle. So does that sound okay to everyone? Okay. Again, any questions, just note them down. If I'm going too fast, let me know as well. Okay, so the first thing we want to do, we want to create a class called operation. What we want from this class actually is that when we put in, so like the example here, we put in 1 + 2 = 3, we want our operation class to take that and split it into a left-hand side, which is this number, so 1, a right-hand side, which would be the other number, 2, the operand, which is what's in the middle, plus, and of course the result, 3. And we want it to have a method, pass input, which kind of does the legwork to set all this up. Okay? So let's focus on that. So if you come into your test, your thingy, test calculator.py, you click on that. So let's write our test for what we want from operation. So let's say we have an instance of operation called op. We want operation, and then we want to pass in a string. So let's go with 1 plus 2 equals 3. Yeah, keep in mind the spaces. All right. So again, in the testing scenario, that's our action. So now we're going to do our assertions of what we expect to come back. Okay? Is everyone still with me? Does anyone need a bit of time to catch up to this, or are we okay? Cool. So if we say assert that op dot, let's call it again left hand side, if you do a dot here, is equal to, so we're expecting our left hand side to come back as 1, right? So that's the first bit of the tests. What else are we expecting? We're expecting our right hand side to come back as 2. Again, we expect the operand to come back as plus, and we expect our result, not reduce, result, can't spell today, to come back as 3. Sound good? And do a little Ctrl S to just save your work, in case anything nasty happens. Does this make sense as a test to everyone? Heard a few no's. Right, so like I mentioned, let me actually touch on that. So we want a case where we pass into operation something like 1 plus 2 equals 3, and it gets split up into the left-hand number, or left-hand side 1, right-hand side 2, the operand plus, and the result 3. Just so we can use that for the rest of our program. Okay? So, if we click on the green arrow here to run this test, we expect it to fail because we haven't written our operation. So again, that has failed. So that is, again, if you think back to all our cycles and diagrams, that's our failing test. Okay? So like we said, we've run the test, it's failed because we have not implemented our operation the way we want it to be.
Just where do you see it's failed?
Underneath here, tests failed. So again, if you just click the green arrow there, it will run your test for you, and then you'd see that little thing underneath pop up. So now we want to actually implement the code that will make this hopefully pass. So what you do, if you go to operation here, you right click, you go to declaration or users. Okay? Right, so go to declaration or usages, and that'll take you to where we need to implement operation. So this is the constructor for operation. So this is how, where we define sort of attributes. So if we look at our diagram here, everything in here should be defined in this bit, essentially. So all the components we want operation to have. So for example, the left-hand side, so we'll do that first. Right, so again, to kind of recap what we're doing here, we're looking to pass this into that So this will go into operation. So that will go in as the string input here. And we're expecting it to split out into these places the way we want it to. So we're going to need a method to do that. And if we want to define that, we'll say def. So let's call it parse input. Let's say it receives string input. So we're going to do this separation using what is called a regular expression. So that's what I already have here for you. So a regular expression is just a simple way in programming just to kind of pick up things based on particular patterns. So here what we're doing is we are wanting to pick up a pattern where it starts with a number or a set of digits. There's a space, and then there's one of these characters, so plus, minus, divide, multiply, a space again, another set of digits, space equals to another set of digits. So what we want ideally is if you think about 1 plus 2 equals to 3. So we want it to fit in that mode. So we want our parse input to do that legwork for us to kind of separate it. So what we'll do is we can define something called pattern. And we say that's equal to RE. So RE is just for regular expression. Dot compile. And we use what I've defined up there. So regex. And then we can say parsed, which is what we expect to be everything broken down into the groups we want, to be pattern dot match string input. So string input is going to be our 1 plus 2 equals 3, again for context. And then we'd like this parsed to be returned. Is that okay? So what we can do in here is actually get the response from parsed. So we can just have a self dot parsed equals to self dot parse input string input. Again, self in, for anyone who's wondering, self in Python is similar to like this in Java. It's all about telling you that it's within this instance of the class. So you're using something within that instance. So self.parsed here is going to come back with all we want from in here. So we can then start picking it out exactly how we want it. So then we can say LHS will be self.parsed, square brackets. So that's the first one here. So we have a 1. Now, quickly, some people will be wondering, because mostly in programming, the first thing item is always 0. So we have a 1 here because of how regular expressions work, essentially. So a 0 would give you the whole thing back, and then a 1 would give you your groupings in these brackets. So obviously, left-hand side, we want just the number, so we go for a 1. Then the next one, your right-hand side, you see 1, 2, 3, set 3. You've got your operand in the middle. Sorry, got carried away. Got your operand in the middle, the 2. And your result is at the end. So that's a 4. Is that okay to everyone? Cool. So the way it looks just now is like, all right, yeah. I'm just trying to give a little explanation. Okay? So when we kind of set this up, it will be like we've pretty much done what we want with operation. So the next step would be to run our tests against this and see if it matches our sort of test case / requirement at the beginning before we started actually creating this class. And just time to what? Is everyone all right to continue? Awesome. So if you go back to test calculator.py, if we run that test, it's actually still failed. But now you can have a bit more. So you can have an error message in here. So actually here it's telling you expected 1 to be equal to 1. But actually what's happened is, so the 1 here is an integer, so a whole number. But in here, we haven't explicitly told our function to set it up as a number. So it's passed it as just text. So we need to actually do that. So for left-hand side, we want to tell it integer. We want the same thing for right-hand side as well. And we want the same thing for result. So the ones that are numbers, we want to tell them to be integers. The operand is plus, so we are happy leaving that as text. Kind of put this down in case anyone's looking at it. Yeah, so the unfortunate thing is that because we've written that one first, that one just fails and it crashes. So it doesn't care about the rest. It just thinks this is wrong, stop here. So what we could actually do, so this isn't for everyone else to do, but if I did that, just for, oh, I didn't even move it to the end. So if I did that, I moved that to the top, if we ran it, so it's actually just picked that up and passed it. Because it's thinking, it's just picking up on that one now. So typically what you'd actually have is that these would all be separate tests. But I think just now, we've kind of found a jinx in this. Oh yeah, as well. So again, just to kind of do that. So if I took that out now, and we can actually just run it from there. It's failed again. Is everyone okay? So again, like I've probably spot the surprise, but if you go back and run your tests, you'd expect it to pass now. And if we did that, it passed. So typically what you do now would be you try different combinations of things to be able to kind of build confidence in what you've written. But for time's sake, we're not going to do that. So what we can just do here is we can make a quick change. So make that 100. So that means we expect that to come back as 100, just to kind of build some sort of self-confidence. Again, you can change it to any number you want on your own, just to kind of check what we've written. And that has passed as well. Okay? So it means that our operation class is how we want it to be, so it works. Does that make sense? So we've got the tests. So like just now with that question, you know, if I went around and started changing things, say for example I took that out and you know there weren't any tests, sometimes that could go unnoticed for weeks, which is a problem. And test-driven development allows you to have these tests already in place immediately before the code even goes anywhere. So wherever it's going with tests alongside, that if anyone's changing it, he can run the tests and then see that he's doing the right thing.
Can you just go back to that previous file that you were playing around
Sorry, the test file? Cool. Yeah. Yeah.
Would you always write your tests so that the expression is being evaluated is listed in that test, or would you get the examples to be read in as groups where you say we expect these to pass, we expect these to fail, and that would be a group of tests together?
Right, so just for the benefit of everyone. So the question he's asking is about, so previously in our calculator feature, we have a group of different examples here and their expected values. So this is our BDD level test, right? So you can actually still use that methodology in your TDD level test, so your more unit level tests. So you can do something with, so in Python you call it subtests, and you give it a list with variables, and so like inputs and outputs, and then it cycles through and does that. I'm not writing that one just now because it will take ages for us to type it, and just for the sake of time. But in your own time, you can have a look at subtests in Python, and I'm pretty sure you find some good methodology and some good examples as well. I'll kind of show you how to use that. Also, we could actually chat about that after, and I can show you. Cool.
Just stupidity. Have you actually done that? You were just saying, the arrow to the left.
Yeah. So the green arrow that states run test. If you don't like that one, you can use the one up top. Okay. So for sake of time, I think we should go on to the next step now. So we've fixed our operation bit, which is going into calculator. So calculator, if you have a look under src, calculator.py, calculator is already set up for you. All right? So what the calculator is doing, so this program, to kind of spend some time, is written so you can kind of take it away and continue. So here we're doing just addition. But the idea here is that a calculator has a validate method, and what it does is that it looks at all its handlers and finds out which one is appropriate for each operation based on the operand. So the handlers will have something called eligible operand. So for addition, it will be a plus. You know, if you're adding a subtraction handler, it will be a minus. And then if it's that one, it tries to check if the operation is correct. So we've got our calculator there as some sort of boilerplate. Again, if you go home and you want to continue this, I'll probably spend some more time on this later on. There's the opportunity for you to expand. Okay. So we talked about the handlers. So we're going to work on the addition handler. So that's the next thing we want to spend some time on now. So your handler is going to have an eligible operand. So again, for addition, that should be plus. It's going to have a method to check operation is correct. We're expecting that method to be what would give us our output, so either true or false, based on operation we pass in. Remember, operation would be one of these that we pass in there. Okay. So, on to the next thing. Let's write a test for our addition handler. All right? So the first thing, we know we're going to need another operation. So again, you can copy and paste from above, or just type out. Let's go with one that's wrong this time. So 1 plus 6, let's say that's equal to 10. And we want to instantiate our handler, and we would say that is equal to addition handler. And I suppose the first thing we want to test would be assert that handler dot, so if we say eligible operand dot is equal to, so again, as we discussed, we expect that to be plus. Right, so that will be the first thing we're checking in this test. After that, we'll say let's get an output, and we'll say that output would be our handler, and check operation is correct as we spotted. We give that our operation op. Now we can check that the output is what we expect. So assert that output is equal to, so in this case it's wrong, so we expect it to be false. just like that. So that would be our test for our addition handler.
How dynamic should these tests usually be? Like here in line 18,
Mhm.
we write out a plus, and then in line 20, we write out a plus again. Should we always have like hard-coded stuff in tests? Or would it be good practice to actually write some code in the test to use the assertion in line 20 to figure out that we passed the plus in line 18? Well, I've never
Yeah.
written a test.
Okay, so yeah, so to kind of repeat the question, so he's talking about in terms of practice, do you want correct me if I'm wrong, do you want your test to sort of be self-contained? Do you want to be able to share values within your tests? Is that right?
Yeah.
So in general, it's kind of, you want your test to be the way you'd write code. So you're fine with sharing variables or values. But for the sake of this, I've just tried to kind of keep both sort of self-contained so we can all see it in one box rather than me telling you this value is coming from somewhere else. So as I mentioned before, there's things called subtests as well, where you can give a list of inputs and outputs, and then you set it up and your code just cycles through each of them when you run one test. Okay? Right, so we're checking it's equal to false based on the input we've put in. So we're putting in 1 plus 6 equals 10. That is not correct math. So we expect it to tell us that that is wrong, which is what we want our function to do. So if I was saying 1 plus 6 equals 7 now, I would make my test to be true, right? So as we go on, we will try another one that's true as well. Is there a question? Yeah, so
this eligible operand, like, is it define something?
So we're going to do that. So that's going to be part of the test to name it as the addition handler. Okay, so we're running out of time, so we'll have to kind of quicken up a bit. Again, the README is there. You know, you can copy and paste if you're falling behind. But again, if we run this test, we see it fails because we have not written up our addition handler. So, in similar fashion, we want to go to declaration or usages. That will take us to where we need to be. So in our constructor, again, if we so addition handler, right click, go to declaration or usages. Okay? So if we have a quick look at our diagram, eligible operand is here. So that means it gets set up in the constructor. So that will mean self dot eligible operand equals to plus, again, because this is the addition handler. Then the next bit we'll want to focus on would be writing this method, which is to check the operations are correct. Right? So what we can do is we can say, right? We can say real output or real result would be equal to, so here what we want to do is actually calculate what the correct answer would be. So as we were talking with that example of 1 plus 6 equals 10, what we want here in this line of code would just be to actually see what that should be. So we'd say operation dot left hand side, so the number, plus the operation dot right hand side. So that would be our real result. And again, the next thing we want to do, we want to say it's true if it's correct. So that means if the result that comes with operation is correct, we want it to be true. And if it's wrong, we want it to be false. So to do that, we do return So we return operation dot result. So that's what's on the other end of our equals to. We do a double equals to real result. So we're saying, essentially, this is just abbreviated for if these two are the same, return true. If they are not, return false. Okay? So that's all we want from our addition handler. So if we do a quick save again. Sorry, I know I'm speeding up, but feel free to come and chat with me after and we can spend time on any bit you're not too clear on. Okay? Right, so if we have our addition handler like that, if you go back to test calculator.py, you want to actually run our test to see that it works. And we do that by clicking the green arrow again, and we see that that test is passed. Right? So we can do a quick tweak to kind of build our confidence. So 1 plus 6 equals 7. So now we'd expect that to be true. That's passed. Okay? So we've got our addition handler sorted. Does that make sense to everyone? Okay. So if we're all good, then, again, coming to this diagram, we've done operation, we've done calculator, we've done handler. So we've done our 2 TDD cycles. And again, looking back on this one, we've kind of finished what's going on in here. Now we want to run our feature tests to see if we're right. And again, we do that by going into terminal. And if you've done it before, you just press your up arrow. Yeah, so if you just press up, it should still be there if you've run that before. Okay. Then we press enter. And now we can look and see from our summary here, our feature has passed, our 5 scenarios have passed. And we can scroll up for context. So look at one of the examples. So we say, given that when I enter this, then the output is false. And them being green means that that is exactly what has happened. If you scroll up, you see all our other examples as well. And that pretty much tells us that we've added the feature we wanted to do with our BDD feature test overall, which we've just run, and our single little smaller test that we've run in our TDD cycles. So for when we're creating operations and when we're writing our addition handler. Does that make sense in general to everyone? Okay. So let's come back here. Okay. Is everyone okay? Right. So at the end of these slides, I know we're running out of time, but I'll quickly take any questions. But in summary, we've looked at what BDD and TDD are. We've looked at how they can work together. We've looked at how they sort of foster collaboration, which is kind of the ideal thing in terms of bringing in product owners and business analysts, and as well as developers and testers together to have conversations. And then we've had a hands-on session to deliver a feature/product, which is our little calculator app. And that has helped us kind of reinforce what we've learned all through. So questions quite quickly. I know you had one before.
Yes, a general question about
Sorry, I think
BDD.
you've got a microphone.
Oh, sorry. It's a general question about BDD and how do you define the limits in the Three Amigos scenario with the stakeholders or the product owner on what are the explicit requirements, so that should be like that because in my mind it's like that, and how many examples do you have? Like, do you need to, because in general you have a test for a for the happy path.
Mm-hmm.
Do you have to test all the possible errors?
Yeah.
You have a so but in real life that could be infinite.
Yeah. So again, just to kind of repeat the question, he's asking about the limit in when you're in your Free Amigo session. So where do you stop? So one other thing a term you also hear in BDD is called deliberate discovery. So like you said, people tend to always want to stick to the happy path. But the idea of deliberate discovery means you're trying to force yourself into the unknown. And the idea is you want to sit down. The hope is that when you have business owners or product owners, developers and testers all together, you'd get most of the different outcomes. and you're more after rules. So rather than individual examples, you'd probably come up with a high-level grouping. So like we talked about calculator app, we can go with 1 + 2 = 3, whatever different math problem, but rather we just go with correct answer gives true. So that's what we'd want to go with. And then what you want to always do also is set a constraint, because like you said, things are infinite. So one of the things we could get with this would be, what if people entered letters instead of numbers? What you'd say is that, right, as part of the feature, if that happens, you just generate an error message and don't care about it, all right? So that's kind of the sort of thinking you have in place. So feature files and things of this nature are not like set in stone. You can always go back and revise them. So if you come up with something else, like, oh, what if someone does this? Or like we've said this now, what if someone puts 2 billion plus something? Do we want a limit? So we can come back and say, right, we need a limit, have a little meeting, add it to the feature file, implement it, and keep going from there. Is that okay?
Yeah.
Right.
In building your feature file, you have a number of phrases, I assume. Sometimes I think some of those phrases will become overloaded and you'll have a lot of variations on a theme. Do you go back to your feature file and rationalize it?
Yeah. So you want to always go back. So it's kind of like with code. You want to be able to refactor your feature files where possible. You want people to be able to come together and, you know, say, right, this doesn't seem quite right. Can we break this down a bit further? Can we have it a bit more self-contained? And then, you know, continue. Because sometimes you can come up with the first draft can be a very ridiculous feature file, you know, with 5 givens, 7 whens, and what have you. But again, the hope is that with this, you look at that and say, right, this is a very complex feature. Let's go back, let's simplify and go forward. Okay?
So how do you manage the whole testing? Because obviously you have BDD and TDD, but we can't automate everything. So how do you manage what is automated versus what is not automated, and how do you provide visibility to the three amigos?
Yeah. So, again, to repeat the question, so she's asking about visibility in terms of our tests. So majority of software tests, I believe, can be automated, especially if it's something that, so like we said here, we're just entering inputs and we're seeing outputs that come out. A lot of things are like that, so we can automate those. But in terms of visibility, what you can do, so BDD framework, so like Behave and a few others, they give you the ability to create reports. So like, I think the Java one, so when I use JGiven, you can get an HTML report that says, right, this is what is happening. So given when, then, that has passed. So it comes out as a nice little file, so you can print that out, give it to the owner and say, right, this passes, and they've got that as the documentation. Yeah. You'd want to always get to that. It's hard to say you've got everything automated, but any test that is repeatable will always be able to be automated. So maybe there's things like, you know, you're trying to break something on purpose. You're not going to really automate that. But again, most of it is something you can automate. So something like a calculator like this, I don't think there's many test cases that, you know, require someone sitting on a laptop for hours, you know, cracking their brain and doing sorts of different things to see how they can break it. I think a lot of them you can kind of come up with and then automate it and write that test underground. Okay.
In the charts for BDD and TDD at the beginning of the slides, there was always an explicit point about the test failing.
Yeah.
What if I have a test that passes by default? Like, I want my application to not leak a secret. So I set it up, I give it a password, and I want that not to show up in the logs. That would pass by default. Why is that not allowed in this methodology? Or
so you'd have to sort of backtrack. So we're doing behavior driven and test driven. So that means behavior and test go first. So your test is going to, in an ideal world, before you add a feature or a product, your test already exists before you've written a line of code. So whatever code, for example, that is keeping your log from leaking a secret, you've already written the test for that before you've written it, if that makes sense. If you're following this to the letter of the law the way it should be.
So another question that kind of feeds into this. Whenever we talked about test, it was always in the singular. Are you supposed to only do one feature, one test at a time, very iteratively? Do you not sometimes come out of a session, 3 amigos or whatever, saying these are the 5 behaviors I want to implement in the next thing?
So what you'd have with that is you'd have 5 versions of this. So you always want to have your work to be quite scalable and measurable. So that's what you get with BDD and TDD. So what you want is you can say, I've done this feature, the next one. And then someone's reviewing that. And again, one of the things I kind of maybe brushed over is the advantage to developers here is it's quite easy for you to know where you stopped. You can just go, right, I've done that feature, this is where I am. As opposed to when you're just writing code without tests, you're like, right, you come back maybe, sometimes even just after lunch, like, right, where did I get up to? You know, what is going on in this for loop, things like that. But that's the idea of having these tests written ahead. So what you want in that scenario where you have multiple tests, so again, kind of similar to what we have in this TDD one, you want to minimize context switching as well. So when you say, right, you've just written a test, you're thinking about that particular functionality, immediately you step over, you write the code to perform that functionality, it passes, you write the next one, you've switched context only when you finished. As opposed to, I've written all these tests, so I've thought of all these 5 different functions, and now I'm coming back here like, right, what is this one supposed to do again? That isn't very efficient, as you probably know as a programmer. So you do want to minimize context switching where possible, and BDD and TDD kind of give you that. One more?
So let's say you're working on a feature, you have many developers working on that same feature. So how do you ensure that you're being efficient in terms of testing, that you're not duplicating the same tests at different layers? So how do you define those tasks?
Right, so if you guys are working on the feature, again, that's the beauty of having BDD and TDD together. So then I expect that, say a feature, so like we used the example of Facebook. So I'd expect that so while you have login functionality, so most times what you find is that one team works on a feature, or in a very small sense, sometimes you have one person. But what you want is that the individual TDD steps are singular person. So you want to say, right, you're handling, for example, the bit that reads in people's usernames. You focus on that, you do your tests, you do that, you send it to review. In an ideal world, the person reviewing that was the one maybe doing, I don't know, the password bit. So you get his, you review it. Again, when you come to refactoring, you can actually look at it and say, right, this guy's code looks a bit cleaner. You can refactor yours, you've got your test as well. You get it to be good. It's also, again, collaboration. It will help you kind of learn from each other as well. As opposed to, just writing code in silos, and when everyone's like, right, how do we test it? You just bombard everything together, and it's like, right, how does this even fit? Does that make sense? Cool. So that's it for questions just now. If you have any other thing you want to add, I'm going to be here when we're having pizza, so just grab me. Hopefully not when I have pizza in my mouth. But yeah, just grab me and I'll be able to take you through anything you need.
3 minutes in total.
Fingers crossed. Right, just to kind of close, what next? So like I mentioned, the exercise is there. I've put a link to the GitHub repo so you can clone it and you can continue in your own time. You can add in subtraction, multiplication, whatever you want. There's details on, so there's 2 sort of links I've put in there, some good blogs on BDD and TDD that I read and they're quite good if you're just getting into it. And then kind of the last thing was that, we all sort of work in this industry, or we're trying to get into this industry. I'd like it if everyone can kind of go away and think, right, how can BDD and TDD sort of help what I'm doing just now? Is this something I can introduce into my work? Is this something I can introduce to my company? Is this something to look into more? And also, if it's something that you think, right, this doesn't fit with anything we're doing, that's fine as well. But it's also good to just kind of have a think and see what value this might be able to add. Well, with that, I'd like to say thank you very much, everyone, and I'll catch you later for a chat.